On the Origin of Species. Page 7. Chapter I. Variation under Domestication. When we look to the individuals of the same variety or subvariety of our older cultivated plants and animals, one of the first points which strikes us is that they generally differ more from each other than do the individuals of any one species or variety in a state of nature. When we reflect on the vast diversity of the plants and animals which have been cultivated, and which have varied during all ages under the most different climates and treatment, I think we are driven to conclude that this great variability is simply due to our domestic productions having been raised under conditions of life not so uniform as, and somewhat different from, those to which the parent species have been exposed under nature. There is also, I think, some probability in the view propounded by Andrew Knight, that this variability may be partly connected with excess of food. It seems pretty clear that organic beings must be exposed during several generations to the new conditions of life to cause any appreciable amount of variation, and that when the organization has once begun to vary, it generally continues to vary for many generations. Page 8. No case is on record of a variable being ceasing to be variable under cultivation. Our oldest cultivated plants, such as wheat, still often yield new varieties. Our oldest domesticated animals are still capable of rapid improvement or modification. It has been disputed at what period of life the causes of variability, whatever they may be, generally act, whether during the early or late period of development of the embryo, or at the instant of conception. Geoffroy St. Hilaire's experiments show that unnatural treatment of the embryo causes monstrosities, and monstrosities cannot be separated by any clear line of distinction from mere variations. But I am strongly inclined to suspect that the most frequent cause of variability may be attributed to the male and female reproductive elements having been affected prior to the act of conception. Several reasons make me believe in this, but the chief one is the remarkable effect which confinement or cultivation has on the function of the reproductive system, this system appearing to be far more susceptible than any other part of the organization to the action of any change in the conditions of life. Nothing is more easy than to tame an animal, and few things more difficult than to get it to breed freely under confinement, even in the many cases when the male and female unite. How many animals there are which will not breed, though living long under not very close confinement in their native country. This is generally attributed to vitiated instincts. But how many cultivated plants display the utmost vigor, and yet rarely or never seed? In some few such cases it has been discovered that very trifling changes, such as a little more or less water at some particular period of growth, will determine whether or not the plant sets a seed. I cannot here enter on the copious details which I have collected on page 9. This curious subject, but to show how singular the laws are which determine the reproduction of animals under confinement, I may just mention that carnivorous animals, even from the tropics, breed in this country pretty freely under confinement, with the exception of the plantigrades or bear family, whereas carnivorous birds, with the rarest exceptions, hardly ever lay fertile eggs. Many exotic plants have pollen utterly worthless, in the same exact condition as in the most sterile hybrids. When, on the one hand, we see domesticated animals and plants, though often weak and sickly, yet breeding quite freely under confinement, and when, on the other hand, we see individuals, though taken young from a state of nature, perfectly tamed, long-lived, and healthy, of which I could give numerous instances, yet having their reproductive system so seriously affected by unperceived causes as to fail in acting, we need not be surprised at this system, when it does act under confinement. Acting not quite regularly, and producing offspring not perfectly like their parents. Sterility has been said to be the bane of horticulture, but on this view we owe variability to the same cause which produces sterility, and variability is the source of all the choicest productions of the garden. I may add, that as some organisms will breed freely under the most unnatural conditions, for instance, the rabbit and ferret kept in hutches, showing that their reproductive system has not been thus affected, so will some animals and plants withstand domestication or cultivation, and very slightly, perhaps hardly more than in a state of nature. A long list could easily be given of sporting plants. By this term gardeners mean a single bud or offset, which suddenly assumes a new and sometimes very different character from that of the rest of the plant. Page 10. Such buds can be propagated by grafting, NC, and sometimes by seed. These sports are extremely rare under nature, but far from rare under cultivation, and in this case we see that the treatment of the parent has affected a bud or offset, and not the ovules or pollen. But it is the opinion of most physiologists that there is no essential difference between a bud and an ovule in their earliest stages of formation, so that, in fact, sports support my view, that variability may be largely attributed to the ovules or pollen, or to both, having been affected by the treatment of the parent prior to the act of conception. These cases anyhow show that variation is not necessarily connected, as some authors have supposed, with the act of generation. Seedlings from the same fruit, and the young of the same litter, sometimes differ considerably from each other, though both the young and the parents, as M. Ler has remarked, have apparently been exposed to exactly the same conditions of life, and this shows how unimportant the direct effects of the conditions of life are in comparison with the laws of reproduction, of growth, and of inheritance, for had the action of the conditions been direct, if any of the young had varied, all would probably have varied in the same manner. To judge how much, in the case of any variation, we should attribute to the direct action of heat, moisture, light, food, NC, is most difficult. My impression is, that with animals such agencies have produced very little direct effect, though apparently more in the case of plants. Under this point of view, Mr. Buckman's recent experiments on plants are extremely valuable. When all or nearly all the individuals exposed to certain conditions are affected in the same way, the change at first appears to be directly due to such conditions, but in some cases it can be shown that quite opposite conditions produce. Page 11. Similar changes of structure. Nevertheless, some slight amount of change may, I think, be attributed to the direct action of the conditions of life as, in some cases, increased size from amount of food, color from particular kinds of food or from light, and perhaps the thickness of fur from climate. Habit also has a decided influence, as in the period of flowering with plants when transported from one climate to another. In animals it has a more marked effect. For instance, I find in the domestic duck that the bones of the wing weigh less and the bones of the leg more, in proportion to the whole skeleton, than do the same bones in the wild duck, and I presume that this change may be safely attributed to the domestic duck flying much less, and walking more, than its wild parent. The great and inherited development of the udders in cows and goats in countries where they are habitually milked, in comparison with the state of these organs in other countries, is another instance of the effect of use. Not a single domestic animal can be named which has not in some country drooping ears, and the view suggested by some authors, that the drooping is due to the disuse of the muscles of the ear, from the animals not being much alarmed by danger, seems probable. There are many laws regulating variation, some few of which can be dimly seen, and will be hereafter briefly mentioned. I will here only allude to what may be called correlation of growth. Any change in the embryo or larva will almost certainly entail changes in the mature animal. In monstrosities, the correlations between quite distinct parts are very curious, and many instances are given in Isidore Geoffroy Saint-Hilaire's great work on this subject. Breeders believe that long limbs are almost always accompanied by an elongated head. Some instances of correlation are quite whimsical, thus. Page 12. Cats with blue eyes are invariably deaf. Color and constitutional peculiarities go together, of which many remarkable cases could be given amongst animals and plants. From the facts collected by Husinger, it appears that white sheep and pigs are differently affected from colored individuals by certain vegetable poisons. Hairless dogs have imperfect teeth. Long-haired and coarse-haired animals are apt to have, as is asserted, long or many horns. Pigeons with feathered feet have skin between their outer toes. Pigeons with short beaks have small feet, and those with long beaks large feet. Hence, if man goes on selecting, and thus augmenting, any peculiarity, he will almost certainly unconsciously modify other parts of the structure, owing to the mysterious laws of the correlation of growth. The result of the various, quite unknown, or dimly seen laws of variation is infinitely complex and diversified. It is well worthwhile carefully to study the several treatises published on some of our old cultivated plants, as on the hyacinth, potato, even the dahlia, and it is really surprising to note the endless points in structure and constitution in which the varieties and subvarieties differ slightly from each other. The whole organization seems to have become plastic, and tends to depart in some small degree from that of the parental type. Any variation which is not inherited is unimportant for us. But the number and diversity of inheritable deviations of structure, both those of slight and those of considerable physiological importance, is endless. Dr. Prosper Lucas's treatise, in 2 large volumes, is the fullest and the best on this subject. No breeder doubts how strong is the tendency to inheritance, like produces like is his fundamental belief. Doubts have been thrown on this principle by theoretical writers alone. When any deviation of structure often appears, and we see it in the page 13. Father and child, we cannot tell whether it may not be due to the same cause having acted on both, but when amongst individuals, apparently exposed to the same conditions, any very rare deviation, due to some extraordinary combination of circumstances, appears in the parent say, once amongst several million individuals and it reappears in the child, the mere doctrine of chances almost compels us to attribute its reappearance to inheritance. Everyone must have heard of cases of albinism, prickly skin, hairy bodies, and appearing in several members of the same family. If strange and rare deviations of structure are truly inherited, less strange and commoner deviations may be freely admitted to be inheritable. Perhaps the correct way of viewing the whole subject would be to look at the inheritance of every character whatever as the rule, and non-inheritance as the anomaly. The laws governing inheritance are quite unknown. No one can say why a peculiarity in different individuals of the same species, or in individuals of different species, is sometimes inherited and sometimes not so, why the child often reverts in certain characters to its grandfather or grandmother or other more remote ancestor, why a peculiarity is often transmitted from one sex to both sexes, or to one sex alone, more commonly but not exclusively to the like sex. It is a fact of some little importance to us, that peculiarities appearing in the males of our domestic breeds are often transmitted either exclusively, or in a much greater degree, to males alone. A much more important rule, which I think may be trusted, is that, at whatever period of life a peculiarity first appears, it tends to appear in the offspring at a corresponding age, though sometimes earlier. In many cases this could not be otherwise, thus the inherited peculiarities in the horns of cattle could appear only in page 14. The offspring when nearly mature. Peculiarities in the silkworm are known to appear at the corresponding caterpillar or cocoon stage. But hereditary diseases and some other facts make me believe that the rule has a wider extension, and that when there is no apparent reason why a peculiarity should appear at any particular age, yet that it does tend to appear in the offspring at the same period at which it first appeared in the parent. I believe this rule to be of the highest importance in explaining the laws of embryology. These remarks are of course confined to the first appearance of the peculiarity, and not to its primary cause, which may have acted on the ovules or male element, in nearly the same manner as in the crossed offspring from a short-horned cow by a long-horned bull. The greater length of horn, though appearing late in life, is clearly due to the male element. Having alluded to the subject of reversion, I may here refer to a statement often made by naturalists Snamley, that our domestic varieties, when run wild, gradually but certainly revert in character to their aboriginal stocks. Hence it has been argued that no deductions can be drawn from domestic races to species in a state of nature. I have in vain endeavored to discover on what decisive facts the above statement has so often and so boldly been made. There would be great difficulty in proving its truth. We may safely conclude that very many of the most strongly marked domestic varieties could not possibly live in a wild state. In many cases we do not know what the aboriginal stock was, and so could not tell whether or not nearly perfect reversion had ensued. It would be quite necessary, in order to prevent the effects of intercrossing, that only a single variety should be turned loose in its new home. Nevertheless, as our varieties certainly do occasionally, page 15, revert in some of their characters to ancestral forms, it seems to me not improbable, that if we could succeed in naturalizing, or were to cultivate, during many generations, the several races, for instance, of the cabbage, in very poor soil, in which case, however, some effect would have to be attributed to the direct action of the poor soil, that they would to a large extent, or even wholly, revert to the wild aboriginal stock. Whether or not the experiment would succeed, is not of great importance for our line of argument, for by the experiment itself the conditions of life are changed. If it could be shown that our domestic varieties manifested a strong tendency to reversions, that is, to lose their acquired characters, whilst kept under the same conditions, and whilst kept in a considerable body, so that free intercrossing might check, by blending together, any slight deviations in their structure, in such case, I grant that we could deduce nothing from domestic varieties in regard to species. But there is not a shadow of evidence in favor of this view, to assert that we could not breed our cart and race horses, long and short-horned cattle, and poultry of various breeds, and esculent vegetables, for an almost infinite number of generations, would be opposed to all experience. I may add, that when under nature the conditions of life do change, variations and reversions of character probably do occur, but natural selection, as will hereafter be explained, will determine how far the new characters thus arising shall be preserved. When we look to the hereditary varieties or races of our domestic animals and plants, and compare them with closely allied species, we generally perceive in each domestic race, as already remarked, less uniformity of character than in true species. Domestic races of the same species, also, often have a somewhat monstrous character, by which I mean, that, although differing, page 16, from each other, and from other species of the same genus, in several trifling respects, they often differ in an extreme degree in some one part, both when compared one with another, and more especially when compared with all the species in nature to which they are nearest allied. With these exceptions, and with that of the perfect fertility of varieties when crossed, a subject hereafter to be discussed, domestic races of the same species differ from each other in the same manner as, only in most cases in a lesser degree than, do closely allied species of the same genus in a state of nature. I think this must be admitted, when we find that there are hardly any domestic races, either amongst animals or plants, which have not been ranked by competent judges as mere varieties, and by other competent judges as the descendants of aboriginally distinct species. If any marked distinction existed between domestic races and species, this source of doubt could not so perpetually recur. It has often been stated that domestic races do not differ from each other in characters of generic value. I think it could be shown that this statement is hardly correct, but naturalists differ widely in determining what characters are of generic value, all such valuations being at present empirical. Moreover, on the view of the origin of genera which I shall presently give, we have no right to expect often to meet with generic differences in our domesticated productions. When we attempt to estimate the amount of structural difference between the domestic races of the same species, we are soon involved in doubt, from not knowing whether they have descended from one or several parent species. This point, if it could be cleared up, would be interesting, if, for instance, it could be shown that the greyhound, bloodhound, terrier, spaniel, and bulldog, which we all know propagate their kinds so truly, were they, page 17, offspring of any single species, then such facts would have great weight in making us doubt about the immutability of the many very closely allied natural species, for instance, of the many foxes inhabiting different quarters of the world. I do not believe, as we shall presently see, that the whole amount of difference between the several breeds of the dog has been produced under domestication. I believe that some small part of the difference is due to their being descended from distinct species. In the case of some other domesticated species, there is presumptive, or even strong evidence, that all the breeds have descended from a single wild stock. It has often been assumed that man has chosen for domestication animals and plants having an extraordinary inherent tendency to vary, and likewise to withstand diverse climates. I do not dispute that these capacities have added largely to the value of most of our domesticated productions, but how could a savage possibly know, when he first tamed an animal, whether it would vary in succeeding generations, and whether it would endure other climates? Has the little variability of the ass or guinea fowl, or the small power of endurance of warmth by the reindeer, or of cold by the common camel, prevented their domestication? I cannot doubt that if other animals and plants, equal in number to our domesticated productions, and belonging to equally diverse classes and countries, were taken from a state of nature, and could be made to breed for an equal number of generations under domestication, they would vary on an average as largely as the parent species of our existing domesticated productions have varied. In the case of most of our anciently domesticated animals and plants, I do not think it is possible to come to any definite conclusion, whether they have descended from one or several wild species. The argument mainly relied on by those who believe in the multiple origin. Page 18. Of our domestic animals is, that we find in the most ancient records, more especially on the monuments of Egypt, much diversity in the breeds, and that some of the breeds closely resemble, perhaps are identical with, those still existing. Even if this latter fact were found more strictly and generally true than seems to me to be the case, what does it show, but that some of our breeds originated there, 4,000 or 5,000 years ago? But Mr. Horner's researches have rendered it in some degree probable that man sufficiently civilized to have manufactured pottery existed in the valley of the Nile 13 or 14,000 years ago, and who will pretend to say how long before these ancient periods, savages, like those of Tierra del Fuego or Australia, who possess a semi-domestic dog, may not have existed in Egypt? The whole subject must, I think, remain vague. Nevertheless, I may, without here entering on any details, state that, from geographical and other considerations, I think it highly probable that our domestic dogs have descended from several wild species. Knowing, as we do, that savages are very fond of taming animals, it seems to me unlikely, in the case of the dog genus, which is distributed in a wild state throughout the world, that since man first appeared one single species alone should have been domesticated. In regard to sheep and goats I can form no opinion. I should think, from facts communicated to me by Mr. Blythe, on the habits, voice, and constitution, N.C., of the humped Indian cattle, that these had descended from a different aboriginal stock from our European cattle, and several competent judges believe that these latter have had more than one wild parent. With respect to horses, from reasons which I cannot give here, I am doubtfully inclined to believe, in opposition to several authors, that all the races have descended from one. Page 19. Wild stock. Mr. Blythe, whose opinion, from his large and varied stores of knowledge, I should value more than that of almost anyone, thinks that all the breeds of poultry have proceeded from the common wild Indian fowl, Gallus bankiva. In regard to ducks and rabbits, the breeds of which differ considerably from each other in structure, I do not doubt that they have all descended from the common wild duck and rabbit. The doctrine of the origin of our several domestic races from several aboriginal stocks, has been carried to an absurd extreme by some authors. They believe that every race which breeds true, let the distinctive characters be ever so slight, has had its wild prototype. At this rate there must have existed at least a score of species of wild cattle, as many sheep, and several goats in Europe alone, and several even within Great Britain. One author believes that there formerly existed in Great Britain 11 wild species of sheep peculiar to it. When we bear in mind that Britain has now hardly one peculiar mammal, and France but few distinct from those of Germany and conversely, and so with Hungary, Spain, N.C., but that each of these kingdoms possesses several peculiar breeds of cattle, sheep, N.C., we must admit that many domestic breeds have originated in Europe, for whence could they have been derived, as these several countries do not possess a number of peculiar species as distinct parent stocks. So it is in India. Even in the case of the domestic dogs of the whole world, which I fully admit have probably descended from several wild species, I cannot doubt that there has been an immense amount of inherited variation. Who can believe that animals closely resembling the Italian Greyhound, the Bloodhound, the Bulldog, or Blenheim Spaniel, and so unlike all wild canids, ever existed freely in a state of nature? It has often been loosely said that all our races of dogs have, page 20, been produced by the crossing of a few aboriginal species, but by crossing we can only get forms in some degree intermediate between their parents, and if we account for our several domestic races by this process, we must admit the former existence of the most extreme forms, as the Italian Greyhound, Bloodhound, Bulldog, and in the wild state. Moreover, the possibility of making distinct races by crossing has been greatly exaggerated. There can be no doubt that a race may be modified by occasional crosses, if aided by the careful selection of those individual mongrels, which present any desired character, but that a race could be obtained nearly intermediate between two extremely different races or species, I can hardly believe. Sir J. C. Bright expressly experimented for this object, and failed. The offspring from the first cross between two pure breeds is tolerably and sometimes, as I have found with pigeons, extremely uniform, and everything seems simple enough, but when these mongrels are crossed one with another for several generations, hardly two of them will be alike, and then the extreme difficulty, or rather utter hopelessness, of the task becomes apparent. Certainly, a breed intermediate between two very distinct breeds could not be got without extreme care and long-continued selection, nor can I find a single case on record of a permanent race having been thus formed. On the breeds of the domestic pigeon believing that it is always best to study some special group, I have, after deliberation, taken up domestic pigeons. I have kept every breed which I could purchase or obtain, and have been most kindly favored with skins from several quarters of the world, more especially by the Honourable W. Elliot from India, and by the Honourable C. Murray from Persia. Many treatises in different languages have been published on pigeons, and some of them are very important, as being of page 21. Considerable antiquity. I have associated with several eminent fanciers, and have been permitted to join two of the London pigeon clubs. The diversity of the breeds is something astonishing. Compare the English carrier and the short-faced tumbler, and see the wonderful difference in their beaks, entailing corresponding differences in their skulls. The carrier, more especially the male bird, is also remarkable from the wonderful development of the carunculated skin about the head, and this is accompanied by greatly elongated eyelids, very large external orifices to the nostrils, and a wide gape of mouth. The short-faced tumbler has a beak in outline almost like that of a finch, and the common tumbler has the singular inherited habit of flying at a great height in a compact flock, and tumbling in the air head over heels. The runt is a bird of great size, with long, massive beak and large feet. Some of the sub-breeds of runts have very long necks, others very long wings and tails, others singularly short tails. The barb is allied to the carrier, but, instead of a very long beak, has a very short and very broad one. The pouter has a much elongated body, wings, and legs, and its enormously developed crop, which it glories in inflating, may well excite astonishment and even laughter. The turbot has a very short and conical beak, with a line of reversed feathers down the breast, and it has the habit of continually expanding slightly the upper part of the esophagus. The Jacobin has the feathers so much reversed along the back of the neck that they form a hood, and it has, proportionally to its size, much elongated wing and tail feathers. The trumpeter and laugher, as their names express, utter a very different coo from the other breeds. The fantail has 30 or even 40 tail feathers, instead of 12 or 14, the normal number in all members of the great pigeon family, and these feathers are kept expanded, and are page 22. Carried so erect that in good birds the head and tail touch, the oil gland is quite aborted. Several other less distinct breeds might be specified. In the skeletons of the several breeds, the development of the bones of the face in length and breadth and curvature differs enormously. The shape, as well as the breadth and length of the ramus of the lower jaw, varies in a highly remarkable manner. The number of the caudal and sacral vertebrae vary, as does the number of the ribs, together with their relative breadth and the presence of processes. The size and shape of the apertures in the sternum are highly variable, so is the degree of divergence and relative size of the two arms of the furcula. The proportional width of the gape of mouth, the proportional length of the eyelids, of the orifice of the nostrils, of the tongue, not always in strict correlation with the length of beak, the size of the crop and of the upper part of the esophagus, the development and abortion of the oil gland, the number of the primary wing and caudal feathers, the relative length of wing and tail to each other and to the body, the relative length of leg and of the feet, the number of scutelle on the toes, the development of skin between the toes, are all points of structure which are variable. The period at which the perfect plumage is acquired varies, as does the state of the down with which the nestling birds are clothed when hatched. The shape and size of the eggs vary. The manner of flight differs remarkably, as does in some breeds the voice and disposition. Lastly, in certain breeds, the males and females have come to differ to a slight degree from each other. Altogether at least a score of pigeons might be chosen, which if shown to an ornithologist, and he were told that they were wild birds, would certainly, I think, be ranked by him as well-defined species. Moreover, I do not believe that any ornithologist would place the page 23. English carrier, the short-faced tumbler, the runt, the barb, pouter, and fantail in the same genus, more especially as in each of these breeds several truly inherited sub-breeds, or species as he might have called them, could be shown him. Great as the differences are between the breeds of pigeons, I am fully convinced that the common opinion of naturalists is correct, namely, that all have descended from the rock pigeon, Columba livia, including under this term several geographical races or subspecies, which differ from each other in the most trifling respects. As several of the reasons which have led me to this belief are in some degree applicable in other cases, I will here briefly give them. If the several breeds are not varieties, and have not proceeded from the rock pigeon, they must have descended from at least 7 or 8 aboriginal stocks, for it is impossible to make the present domestic breeds by the crossing of any lesser number. How, for instance, could a pouter be produced by crossing 2 breeds unless one of the parent stocks possessed the characteristic enormous crop? The supposed aboriginal stocks must all have been rock pigeons, that is, not breeding or willingly perching on trees. But besides C. livia, with its geographical subspecies, only 2 or 3 other species of rock pigeons are known, and these have not any of the characters of the domestic breeds. Hence the supposed aboriginal stocks must either still exist in the countries where they were originally domesticated, and yet be unknown to ornithologists, and this, considering their size, habits, and remarkable characters, seems very improbable, or they must have become extinct in the wild state. But birds breeding on precipices, and good flyers, are unlikely to be exterminated, and the common rock pigeon, which has the same habits with the domestic breeds, has not been exterminated. Page 24. Even on several of the smaller British islets, or on the shores of the Mediterranean. Hence the supposed extermination of so many species having similar habits with the rock pigeon seems to me a very rash assumption. Moreover, the several above-named domesticated breeds have been transported to all parts of the world, and, therefore, some of them must have been carried back again into their native country, but not one has ever become wild or feral, though the dovecot pigeon, which is the rock pigeon in a very slightly altered state, has become feral in several places. Again, all recent experience shows that it is most difficult to get any wild animal to breed freely under domestication, yet on the hypothesis of the multiple origin of our pigeons, it must be assumed that at least 7 or 8 species were so thoroughly domesticated in ancient times by half-civilized man, as to be quite prolific under confinement. An argument, as it seems to me, of great weight, and applicable in several other cases, is, that the above specified breeds, though agreeing generally in constitution, habits, voice, coloring, and in most parts of their structure, with the wild rock pigeon, yet are certainly highly abnormal in other parts of their structure. We may look in vain throughout the whole great family of Columba for a beak like that of the English carrier, or that of the short-faced tumbler, or barb, for reversed feathers like those of the Jacobin, for a crop like that of the pouter, for tail feathers like those of the fantail. Hence it must be assumed not only that half-civilized man succeeded in thoroughly domesticating several species, but that he intentionally or by chance picked out extraordinarily abnormal species, and further, that these very species have since all become extinct or unknown. So many strange contingencies seem to me improbable in the highest degree. Page 25. Some facts in regard to the coloring of pigeons well deserve consideration. The rock pigeon is of a slaty blue, and has a white rump. The Indian subspecies, C. intermedia of Strickland, having it bluish. The tail has a terminal dark bar, with the bases of the outer feathers externally edged with white. The wings have 2 black bars. Some semi-domestic breeds and some apparently truly wild breeds have, besides the 2 black bars, the wings checkered with black. These several marks do not occur together in any other species of the whole family. Now, in every one of the domestic breeds, taking thoroughly well-bred birds, all the above marks, even to the white edging of the outer tail feathers, sometimes concur perfectly developed. Moreover, when 2 birds belonging to 2 distinct breeds are crossed, neither of which is blue or has any of the above specified marks, the mongrel offspring are very apt suddenly to acquire these characters. For instance, I crossed some uniformly white fantails with some uniformly black barbs, and they produced mottled brown and black birds. These I again crossed together, and one grandchild of the pure white fantail and pure black barb was of as beautiful a blue color, with the white rump, double black wing bar, and barred and white-edged tail feathers, as any wild rock pigeon. We can understand these facts, on the well-known principle of reversion to ancestral characters, if all the domestic breeds have descended from the rock pigeon. But if we deny this, we must make one of the 2 following highly improbable suppositions. Either, firstly, that all the several imagined aboriginal stocks were colored and marked like the rock pigeon, although no other existing species is thus colored and marked, so that in each separate breed there might be a tendency to revert to the very same colors and markings. Or, secondly, page 26. That each breed, even the purest, has within a dozen or, at most, within a score of generations, been crossed by the rock pigeon. I say within a dozen or 20 generations, for we know of no fact countenancing the belief that the child ever reverts to some one ancestor, removed by a greater number of generations. In a breed which has been crossed only once with some distinct breed, the tendency to reversion to any character derived from such cross will naturally become less and less, as in each succeeding generation there will be less of the foreign blood. But when there has been no cross with a distinct breed, and there is a tendency in both parents to revert to a character, which has been lost during some former generation, this tendency, for all that we can see to the contrary, may be transmitted undiminished for an indefinite number of generations. These two distinct cases are often confounded in treatises on inheritance. Lastly, the hybrids or mongrels from between all the domestic breeds of pigeons are perfectly fertile. I can state this from my own observations, purposely made, on the most distinct breeds. Now, it is difficult, perhaps impossible, to bring forward one case of the hybrid offspring of two animals clearly distinct being themselves perfectly fertile. Some authors believe that long-continued domestication eliminates this strong tendency to sterility. From the history of the dog, I think there is some probability in this hypothesis, if applied to species closely related together, though it is unsupported by a single experiment. But to extend the hypothesis so far as to suppose that species, aboriginally as distinct as carriers, tumblers, pouters, and fantails now are, should yield offspring perfectly fertile, inter se, seems to me rash in the extreme. From these several reasons, namely, the improbability of man having formerly got 7 or 8 supposed. Page 27. Species of pigeons to breed freely under domestication, these supposed species being quite unknown in a wild state, and their becoming nowhere feral, these species having very abnormal characters in certain respects, as compared with all other columba, though so like in most other respects to the rock pigeon, the blue color and various marks occasionally appearing in all the breeds, both when kept pure and when crossed, the mongrel offspring being perfectly fertile, from these several reasons. Taken together, I can feel no doubt that all our domestic breeds have descended from the columba livia with its geographical subspecies. In favor of this view, I may add, firstly, that C. livia, or the rock pigeon, has been found capable of domestication in Europe and in India, and that it agrees in habits and in a great number of points of structure with all the domestic breeds. Secondly, although an English carrier or short-faced tumbler differs immensely in certain characters from the rock pigeon, yet by comparing the several sub-breeds of these varieties, more especially those brought from distant countries, we can make an almost perfect series between the extremes of structure. Thirdly, those characters which are mainly distinctive of each breed, for instance the wattle and length of beak of the carrier, the shortness of that of the tumbler, and the number of tail feathers in the fantail, are in each breed eminently variable, and the explanation of this fact will be obvious when we come to treat of selection. Fourthly, pigeons have been watched, and tended with the utmost care, and loved by many people. They have been domesticated for thousands of years in several quarters of the world. The earliest known record of pigeons is in the 5th Egyptian dynasty, about 3000 BC, as was pointed out to me by Professor Lepsius, but Mr. Birch informs me that pigeons are given in a bill. Page 28. Of fare in the previous dynasty. In the time of the Romans, as we hear from Pliny, immense prices were given for pigeons, Nay, they are come to this pass, that they can reckon up their pedigree and race. Pigeons were much valued by Akbar Khan in India, about the year 1600, never less than 20,000 pigeons were taken with the court. The monarchs of Iran and Turan sent him some very rare birds, and, continues the courtly historian, His Majesty by crossing the breeds, which method was never practiced before, has improved them astonishingly. About this same period the Dutch were as eager about pigeons as were the old Romans. The paramount importance of these considerations in explaining the immense amount of variation which pigeons have undergone, will be obvious when we treat of selection. We shall then, also, see how it is that the breeds so often have a somewhat monstrous character. It is also a most favorable circumstance for the production of distinct breeds, that male and female pigeons can be easily mated for life, and thus different breeds can be kept together in the same aviary. I have discussed the probable origin of domestic pigeons at some, yet quite insufficient, length, because when I first kept pigeons and watched the several kinds, knowing well how true they bred, I felt fully as much difficulty in believing that they could have descended from a common parent, as any naturalist could in coming to a similar conclusion in regard to the many species of finches, or other large groups of birds, in nature. One circumstance has struck me much, namely, that all the breeders of the various domestic animals and the cultivators of plants, with whom I have ever conversed, or whose treatises I have read, are firmly convinced that the several breeds to which each has attended, are descended from so many aboriginally distinct species. Page 29. Ask, as I have asked, a celebrated raiser of Hereford cattle, whether his cattle might not have descended from longhorns, and he will laugh you to scorn. I have never met a pigeon, or poultry, or duck, or rabbit fancier, who was not fully convinced that each main breed was descended from a distinct species. Van Mons, in his treatise on pears and apples, shows how utterly he disbelieves that the several sorts, for instance a Ribston pippin or Codlin apple, could ever have proceeded from the seeds of the same tree. Innumerable other examples could be given. The explanation, I think, is simple. From long-continued study they are strongly impressed with the differences between the several races, and though they well know that each race varies slightly, for they win their prizes by selecting such slight differences, yet they ignore all general arguments, and refuse to sum up in their minds slight differences accumulated during many successive generations. May not those naturalists who, knowing far less of the laws of inheritance than does the breeder, and knowing no more than he does of the intermediate links in the long lines of descent, yet admit that many of our domestic races have descended from the same parents, may they not learn a lesson of caution, when they deride the idea of species in a state of nature being lineal descendants of other species? Selection X. Let us now briefly consider the steps by which domestic races have been produced, either from one or from several allied species. Some little effect may, perhaps, be attributed to the direct action of the external conditions of life, and some little to habit, but he would be a bold man who would account by such agencies for the differences of a dray and race horse, a greyhound and bloodhound, a carrier and tumbler pigeon. One of the most remarkable features in our domesticated races, page 30, is that we see in them adaptation, not indeed to the animal's or plant's own good, but to man's use or fancy. Some variations useful to him have probably arisen suddenly, or by one step. Many botanists, for instance, believe that the fuller's teasel, with its hooks, which cannot be rivaled by any mechanical contrivance, is only a variety of the wild Dipes acus, and this amount of change may have suddenly arisen in a seedling. So it has probably been with the turnspit dog, and this is known to have been the case with the Ancon sheep. But when we compare the dray horse and race horse, the dromedary and camel, the various breeds of sheep fitted either for cultivated land or mountain pasture, with the wool of one breed good for one purpose, and that of another breed for another purpose, when we compare the many breeds of dogs, each good for man in very different ways, when we compare the gamecock, so pertinacious in battle, with other breeds so little quarrelsome, with everlasting layers which never desire to sit, and with the bantam so small and elegant, when we compare the host of agricultural, culinary, orchard, and flower garden races of plants, most useful to man at different seasons and for different purposes, or so beautiful in his eyes, we must, I think, look further than to mere variability. We cannot suppose that all the breeds were suddenly produced as perfect and as useful as we now see them. Indeed, in several cases, we know that this has not been their history. The key is man's power of accumulative selection. Nature gives successive variations, man adds them up in certain directions useful to him. In this sense he may be said to make for himself useful breeds. The great power of this principle of selection is not hypothetical. It is certain that several of our eminent breeders have, even within a single lifetime, modified to page 31. A large extent some breeds of cattle and sheep. In order fully to realize what they have done, it is almost necessary to read several of the many treatises devoted to this subject, and to inspect the animals. Breeders habitually speak of an animal's organization as something quite plastic, which they can model almost as they please. If I had space I could quote numerous passages to this effect from highly competent authorities. Watt, who was probably better acquainted with the works of agriculturists than almost any other individual, and who was himself a very good judge of an animal, speaks of the principle of selection as that which enables the agriculturist, not only to modify the character of his flock, but to change it altogether. It is the magician's wand, by means of which he may summon into life whatever form and mold he pleases. Lord Somerville, speaking of what breeders have done for sheep, says X. It would seem as if they had chalked out upon a wall a form perfect in itself, and then had given it existence. That most skillful breeder, Sir John Sebright, used to say, with respect to pigeons, that he would produce any given feather in 3 years, but it would take him 6 years to obtain head and beak. In Saxony the importance of the principle of selection in regard to merino sheep is so fully recognized, that men follow it as a trade. The sheep are placed on a table and are studied, like a picture by a connoisseur. This is done 3 times at intervals of months, and the sheep are each time marked and classed, so that the very best may ultimately be selected for breeding. What English breeders have actually effected is proved by the enormous prices given for animals with a good pedigree, and these have now been exported to almost every quarter of the world. The improvement is by no means generally due to crossing different breeds. Page 32. All the best breeders are strongly opposed to this practice, except sometimes amongst closely allied sub-breeds. And when a cross has been made, the closest selection is far more indispensable even than in ordinary cases. If selection consisted merely in separating some very distinct variety, and breeding from it, the principle would be so obvious as hardly to be worth notice, but its importance consists in the great effect produced by the accumulation in one direction, during successive generations, of differences absolutely inappreciable by an uneducated eye, differences which I for one have vainly attempted to appreciate. Not one man in 1,000 has accuracy of eye and judgment sufficient to become an eminent breeder. If gifted with these qualities, and he studies his subject for years, and devotes his lifetime to it with indomitable perseverance, he will succeed, and may make great improvements. If he wants any of these qualities, he will assuredly fail. Few would readily believe in the natural capacity and years of practice requisite to become even a skillful pigeon fancier. The same principles are followed by horticulturists, but the variations are here often more abrupt. No one supposes that our choicest productions have been produced by a single variation from the aboriginal stock. We have proofs that this is not so in some cases, in which exact records have been kept. Thus, to give a very trifling instance, the steadily increasing size of the common gooseberry may be quoted. We see an astonishing improvement in many florists' flowers, when the flowers of the present day are compared with drawings made only 20 or 30 years ago. When a race of plants is once pretty well established, the seed raisers do not pick out the best plants, but merely go over their seed beds, and pull up the rogues, as they call the plants that deviate from the proper standard. With animals this. Page 33. Kind of selection is, in fact, also followed, for hardly anyone is so careless as to allow his worst animals to breed. In regard to plants, there is another means of observing the accumulated effects of selection, namely, by comparing the diversity of flowers in the different varieties of the same species in the flower garden, the diversity of leaves, pods, or tubers, or whatever part is valued, in the kitchen garden, in comparison with the flowers of the same varieties, and the diversity of fruit of the same species in the orchard, in comparison with the leaves and flowers of the same set of varieties. See how different the leaves of the cabbage are, and how extremely alike the flowers, how unlike the flowers of the heartsease are, and how alike the leaves, how much the fruit of the different kinds of gooseberries differ in size, color, shape, and hairiness, and yet the flowers present very slight differences. It is not that the varieties which differ largely in some one point do not differ at all in other points. This is hardly ever, perhaps never, the case. The laws of correlation of growth, the importance of which should never be overlooked, will ensure some differences, but, as a general rule, I cannot doubt that the continued selection of slight variations, either in the leaves, the flowers, or the fruit, will produce races differing from each other chiefly in these characters. It may be objected that the principle of selection has been reduced to methodical practice for scarcely more than 3/4 of a century. It has certainly been more attended to of late years, and many treatises have been published on the subject, and the result has been, in a corresponding degree, rapid and important. But it is very far from true that the principle is a modern discovery. I could give several references to the full acknowledgement of the importance of the principle in works of high antiquity. In rude and barbarous periods. Page 34. Of English history, choice animals were often imported, and laws were passed to prevent their exportation. The destruction of horses under a certain size was ordered, and this may be compared to the roguing of plants by nurserymen. The principle of selection I find distinctly given in an ancient Chinese encyclopedia. Explicit rules are laid down by some of the Roman classical writers. From passages in Genesis, it is clear that the color of domestic animals was at that early period attended to. Savages now sometimes cross their dogs with wild canine animals, to improve the breed, and they formerly did so, as is attested by passages in Pliny. The savages in South Africa match their draft cattle by color, as do some of the Eskimo their teams of dogs. Livingstone shows how much good domestic breeds are valued by the Negroes of the interior of Africa who have not associated with Europeans. Some of these facts do not show actual selection, but they show that the breeding of domestic animals was carefully attended to in ancient times, and is now attended to by the lowest savages. It would, indeed, have been a strange fact, had attention not been paid to breeding, for the inheritance of good and bad qualities is so obvious. At the present time, eminent breeders try by methodical selection, with the distinct object in view, to make a new strain or sub-breed, superior to anything existing in the country. But, for our purpose, a kind of selection, which may be called unconscious, and which results from every one trying to possess and breed from the best individual animals, is more important. Thus, a man who intends keeping pointers naturally tries to get as good dogs as he can, and afterwards breeds from his own best dogs, but he has no wish or expectation of permanently altering the breed. Nevertheless, I cannot doubt that this process, continued during centuries, page 35, would improve and modify any breed, in the same way as Bakewell, Collins, N.C., by this very same process, only carried on more methodically, did greatly modify, even during their own lifetimes, the forms and qualities of their cattle. Slow and insensible changes of this kind could never be recognized unless actual measurements or careful drawings of the breeds in question had been made long ago, which might serve for comparison. In some cases, however, unchanged, or but little changed individuals of the same breed may be found in less civilized districts, where the breed has been less improved. There is reason to believe that King Charles's Spaniel has been unconsciously modified to a large extent since the time of that monarch. Some highly competent authorities are convinced that the setter is directly derived from the Spaniel, and has probably been slowly altered from it. It is known that the English Pointer has been greatly changed within the last century, and in this case the change has, it is believed, been chiefly affected by crosses with the foxhound, but what concerns us is, that the change has been effected unconsciously and gradually, and yet so effectually, that, though the old Spanish Pointer certainly came from Spain, Mr. Borrow has not seen, as I am informed by him, any native dog in Spain like our Pointer. By a similar process of selection, and by careful training, the whole body of English race horses have come to surpass in fleetness and size the parent Arab stock, so that the latter, by the regulations for the Goodwood races, are favoured in the weights they carry. Lord Spencer and others have shown how the cattle of England have increased in weight and in early maturity, compared with the stock formerly kept in this country. By comparing the accounts given in old pigeon treatises of carriers and tumblers with these breeds as now existing in Britain. Page 36. India, and Persia, we can, I think, clearly trace the stages through which they have insensibly passed, and come to differ so greatly from the rock pigeon. Youatt gives an excellent illustration of the effects of a course of selection, which may be considered as unconsciously followed, in so far that the breeders could never have expected or even have wished to have produced the result which ensued snamly, the production of two distinct strains. The two flocks of Leicester sheep kept by Mr. Buckley and Mr. Burgess, as Mr. Youatt remarks, have been purely bred from the original stock of Mr. Bakewell for upwards of 50 years. There is not a suspicion existing in the mind of anyone at all acquainted with the subject that the owner of either of them has deviated in any one instance from the pure blood of Mr. Bakewell's flock, and yet the difference between the sheep possessed by these two gentlemen is so great that they have the appearance of being quite different varieties. If there exist savages so barbarous as never to think of the inherited character of the offspring of their domestic animals, yet any one animal particularly useful to them, for any special purpose, would be carefully preserved during famines and other accidents, to which savages are so liable, and such choice animals would thus generally leave more offspring than the inferior ones, so that in this case there would be a kind of unconscious selection going on. We see the value set on animals even by the barbarians of Tierra del Fuego, by their killing and devouring their old women, in times of dearth, as of less value than their dogs. In plants the same gradual process of improvement, through the occasional preservation of the best individuals, whether or not sufficiently distinct to be ranked at their first appearance as distinct varieties, and whether, page 37, or not two or more species or races have become blended together by crossing, may plainly be recognized in the increased size and beauty which we now see in the varieties of the heartsease, rose, pelargonium, dahlia, and other plants, when compared with the older varieties or with their parent stocks. No one would ever expect to get a first-rate heartsease or dahlia from the seed of a wild plant. No one would expect to raise a first-rate melting pear from the seed of the wild pear, though he might succeed from a poor seedling growing wild, if it had come from a garden stock. The pear, though cultivated in classical times, appears, from Pliny's description, to have been a fruit of very inferior quality. I have seen great surprise expressed in horticultural works at the wonderful skill of gardeners, in having produced such splendid results from such poor materials, but the art, I cannot doubt, has been simple, and, as far as the final result is concerned, has been followed almost unconsciously. It has consisted in always cultivating the best known variety, sowing its seeds, and, when a slightly better variety has chanced to appear, selecting it, and so onwards. But the gardeners of the classical period, who cultivated the best pear they could procure, never thought what splendid fruit we should eat, though we owe our excellent fruit, in some small degree, to their having naturally chosen and preserved the best varieties they could anywhere find. A large amount of change in our cultivated plants, thus slowly and unconsciously accumulated, explains, as I believe, the well-known fact, that in a vast number of cases we cannot recognize, and therefore do not know, the wild parent stocks of the plants which have been longest cultivated in our flower and kitchen gardens. If it has taken centuries or thousands of years to improve or modify most of our plants up to their present, page 38, standard of usefulness to man, we can understand how it is that neither Australia, the Cape of Good Hope, nor any other region inhabited by quite uncivilized man, has afforded us a single plant worth culture. It is not that these countries, so rich in species, do not by a strange chance possess the aboriginal stocks of any useful plants, but that the native plants have not been improved by continued selection up to a standard of perfection comparable with that given to the plants in countries anciently civilized. In regard to the domestic animals kept by uncivilized man, it should not be overlooked that they almost always have to struggle for their own food, at least during certain seasons. And in two countries very differently circumstanced, individuals of the same species, having slightly different constitutions or structure, would often succeed better in the one country than in the other, and thus by a process of natural selection, as will hereafter be more fully explained, two sub-breeds might be formed. This, perhaps, partly explains what has been remarked by some authors, namely, that the varieties kept by savages have more of the character of species than the varieties kept in civilized countries. On the view here given of the all-important part which selection by man has played, it becomes at once obvious how it is that our domestic races show adaptation in their structure or in their habits to man's wants or fancies. We can, I think, further understand the frequently abnormal character of our domestic races, and likewise their differences being so great in external characters and relatively so slight in internal parts or organs. Man can hardly select, or only with much difficulty, any deviation of structure excepting such as is externally visible, and indeed he rarely cares for what is internal. He can never act by selection, excepting on variations. Page 39. Which are first given to him in some slight degree by nature. No man would ever try to make a fantail, till he saw a pigeon with a tail developed in some slight degree in an unusual manner, or a pouter till he saw a pigeon with a crop of somewhat unusual size, and the more abnormal or unusual any character was when it first appeared, the more likely it would be to catch his attention. But to use such an expression as trying to make a fantail, is, I have no doubt, in most cases, utterly incorrect. The man who first selected a pigeon with a slightly larger tail, never dreamed what the descendants of that pigeon would become through long-continued, partly unconscious and partly methodical selection. Perhaps the parent bird of all fantails had only 14 tail feathers somewhat expanded, like the present Java fantail, or like individuals of other and distinct breeds, in which as many as 17 tail feathers have been counted. Perhaps the first pouter pigeon did not inflate its crop much more than the turbot now does the upper part of its syphagus, a habit which is disregarded by all fanciers, as it is not one of the points of the breed. Nor let it be thought that some great deviation of structure would be necessary to catch the fancier's eye. He perceives extremely small differences, and it is in human nature to value any novelty, however slight, in one's own possession. Nor must the value which would formerly be set on any slight differences in the individuals of the same species, be judged of by the value which would now be set on them, after several breeds have once fairly been established. Many slight differences might, and indeed do now, arise amongst pigeons, which are rejected as faults or deviations from the standard of perfection of each breed. The common goose has not given rise to any marked varieties, hence the thou louse and the common breed, which differ only in color, that. Page 40. Most fleeting of characters, have lately been exhibited as distinct at our poultry shows. I think these views further explain what has sometimes been noticed, namely, that we know nothing about the origin or history of any of our domestic breeds. But, in fact, a breed, like a dialect of a language, can hardly be said to have had a definite origin. A man preserves and breeds from an individual with some slight deviation of structure, or takes more care than usual in matching his best animals and thus improves them, and the improved individuals slowly spread in the immediate neighborhood. But as yet they will hardly have a distinct name, and from being only slightly valued, their history will be disregarded. When further improved by the same slow and gradual process, they will spread more widely, and will get recognized as something distinct and valuable, and will then probably first receive a provincial name. In semi-civilized countries, with little free communication, the spreading and knowledge of any new sub-breed will be a slow process. As soon as the points of value of the new subbreed are once fully acknowledged, the principle, as I have called it, of unconscious selection will always tend perhaps more at one period than at another, as the breed rises or falls in fashions perhaps more in one district than in another, according to the state of civilization of the inhabitants, slowly to add to the characteristic features of the breed, whatever they may be. But the chance will be infinitely small of any record having been preserved of such slow, varying, and insensible changes. I must now say a few words on the circumstances, favorable, or the reverse, to man's power of selection. A high degree of variability is obviously favorable, as freely giving the materials for selection to work on, not that mere individual differences are not amply. Page 41. Sufficient, with extreme care, to allow of the accumulation of a large amount of modification in almost any desired direction. But as variations manifestly useful or pleasing to man appear only occasionally, the chance of their appearance will be much increased by a large number of individuals being kept, and hence this comes to be of the highest importance to success. On this principle Marshall has remarked, with respect to the sheep of parts of Yorkshire, that as they generally belong to poor people, and are mostly, in small lots, they never can be improved. On the other hand, nurserymen, from raising large stocks of the same plants, are generally far more successful than amateurs in getting new and valuable varieties. The keeping of a large number of individuals of a species in any country requires that the species should be placed under favorable conditions of life, so as to breed freely in that country. When the individuals of any species are scanty, all the individuals, whatever their quality may be, will generally be allowed to breed, and this will effectually prevent selection. But probably the most important point of all, is, that the animal or plant should be so highly useful to man, or so much valued by him, that the closest attention should be paid to even the slightest deviation in the qualities or structure of each individual. Unless such attention be paid, nothing can be effected. I have seen it gravely remarked, that it was most fortunate that the strawberry began to vary just when gardeners began to attend closely to this plant. No doubt the strawberry had always varied since it was cultivated, but the slight varieties had been neglected. As soon, however, as gardeners picked out individual plants with slightly larger, earlier, or better fruit, and raised seedlings from them, and again picked out the best seedlings and bred from them, then, there appeared, aided by some. Page 42. Crossing with distinct species, those many admirable varieties of the strawberry which have been raised during the last 30 or 40 years. In the case of animals with separate sexes, facility in preventing crosses is an important element of success in the formation of new races, at least, in a country which is already stocked with other races. In this respect, enclosure of the land plays a part. Wandering savages or the inhabitants of open plains rarely possess more than one breed of the same species. Pigeons can be mated for life, and this is a great convenience to the fancier, for thus many races may be kept true, though mingled in the same aviary, and this circumstance must have largely favored the improvement and formation of new breeds. Pigeons, I may add, can be propagated in great numbers and at a very quick rate, and inferior birds may be freely rejected, as when killed they serve for food. On the other hand, cats, from their nocturnal rambling habits, cannot be matched, and, although so much valued by women and children, we hardly ever see a distinct breed kept up. Such breeds as we do sometimes see are almost always imported from some other country, often from islands. Although I do not doubt that some domestic animals vary less than others, yet the rarity or absence of distinct breeds of the cat, the donkey, peacock, goose, etc. may be attributed in main part to selection not having been brought into play, in cats, from the difficulty in pairing them, in donkeys, from only a few being kept by poor people, and little attention paid to their breeding, in peacocks, from not being very easily reared and a large stock not kept, in geese, from being valuable only for two purposes, food and feathers, and more especially from no pleasure having been felt in the display of distinct breeds. To sum up on the origin of our domestic races of page 43. Animals and plants. I believe that the conditions of life, from their action on the reproductive system, are so far of the highest importance as causing variability. I do not believe that variability is an inherent and necessary contingency, under all circumstances, with all organic beings, as some authors have thought. The effects of variability are modified by various degrees of inheritance and of reversion. Variability is governed by many unknown laws, more especially by that of correlation of growth. Something may be attributed to the direct action of the conditions of life. Something must be attributed to use and disuse. The final result is thus rendered infinitely complex. In some cases, I do not doubt that the intercrossing of species, aboriginally distinct, has played an important part in the origin of our domestic productions. When in any country several domestic breeds have once been established, their occasional intercrossing, with the aid of selection, has, no doubt, largely aided in the formation of new sub-breeds, but the importance of the crossing of varieties has, I believe, been greatly exaggerated, both in regard to animals and to those plants which are propagated by seed. In plants which are temporarily propagated by cuttings, buds, etc., the importance of the crossing both of distinct species and of varieties is immense, for the cultivator here quite disregards the extreme variability both of hybrids and mongrels, and the frequent sterility of hybrids, but the cases of plants not propagated by seed are of little importance to us, for their endurance is only temporary. Over all these causes of change I am convinced that the accumulative action of selection, whether applied methodically and more quickly or unconsciously and more slowly, but more efficiently, is by far the predominant power.